Hello everyone. So far we have studied pure statistics in the sense quartile deviation, standard deviation, mean, median, mode. So everything is based on calculations. So in this session let me start with the new concept in the 4th unit only. So after quartile deviation there is a concept called probability. As you already familiar about this word, you might have studied this concept in your class 10 as well as in your class 11 and 12. So anyhow, let me give you a brief introduction about probability. So probability, the word itself indicates that probably, generally we use in our life the word probability, right? So most probably tomorrow college will be there. Most probably she'll come tomorrow. Most probably it will happen. Most probably exam will be there. So probably in the sense it is chances. So the word probability is none other than a chances of occurrence of something. Fine. So before getting to the topic of probability, let me give you a concept of a few terminologies, that is technical terms. First one is called as random experiment. Random experiment. So experiment in the sense whatever may be the action we do, that is none other than a random experiment. If we say a particular action is said to be a random experiment, if it should satisfy two conditions. First condition is that it has more than one possible output. More than one possible output. And second one is that it is not possible to predict the output in advance. That is, we cannot predict the output. We cannot predict output in advance. I'll give you just one example. Die, I think you are familiar with the dice, right? So if you're going to throw a die, it will be having more than one output, right? Either you can get, you will be having the numbers right from 1 to 6 on a die. So if you throw it, either you will get 1 or 2 or 3 or 4 or 5 or 6. So definitely it has more than one output. So it satisfies first condition. Second one is we cannot predict output in advance, in the sense among the numbers 1 to 6, if we throw the die, we don't know that which number we are going to get, right? So we say that is a random experiment. That is, throwing a die is a random experiment. Similarly, tossing a coin. So if you toss the coin, there will be two possibilities. That is two outputs, right? Either you should get head or you should get tail. So it has more than one output. Second condition, we cannot predict output in advance, right? So if you toss the coin, then also we cannot say whether we are going to get a head or we are going to get tail. So that is an example for random experiment. An experiment is said to be a random experiment only when if it satisfies two conditions. First one is more than one possible output. In the sense it has more than one possible output, and it should not, output of the experiment should not be known in advance. Now, second terminology is outcome. Outcome in the sense the possible result of the random experiment. I'll give you one reference example. Suppose for a random experiment, I'll take it as tossing a coin. Tossing a coin. Let me take a random experiment of tossing a coin. Outcome in the sense all the possible results of this random experiment. So when you're going to toss a coin, the possible outcomes are either head or tail. So getting a head or getting a tail is the only outcome of tossing a coin. So all possible outcomes are called as all possible results are called as outcomes of a experiment. Fine. And the third one is sample space. Sample space is usually denoted by S. Sample space is none other than it is set of all possible outcomes is called as sample space. In the sense, if you are going to consider a tossing a coin, so sample space in that case will be head and tail. Only possibility is head and tail. Suppose if you are going to toss two coins at a time, then the sample space will be, for the first time in one coin you will get head and tail. In the other coin you will get tail and head. So other thing will be in the first coin. Let me take first value refer to first coin and second value refer to second coin. In the first coin, head, then tail, tail. So these are the possible outcomes when you toss two coins. So all the possible outcomes is called as sample space. Fine. Next thing is event. Event is none other than any possible outcome. Wordings is different. It is all the possible outcome. It is any possible outcome. I'll give you an example of this random experiment. So first event is getting a head, right? Second event is getting tail. Clear? Event is none other than any possible outcome of a random experiment. Let me consider a random experiment as tossing a coin. So if you're going to toss a coin, either you will get head or you will get tail. So getting head is one event and getting tail is another event. So event is any possible outcome of a random experiment. Fine. Next, mutually exclusive event. Mutually exclusive event. Now, two events are said to be mutually exclusive when both cannot happen simultaneously, both cannot happen together. I'll give you simple example. When you toss a coin, and as I said in the random experiment, so when you toss a coin, either you will get head or you will get a tail. You cannot get both at a time, right? So that kind of event is called as mutually exclusive event. Two events are said to be mutually exclusive. They cannot happen together. Let me take first event as getting head, second event as getting tail. So they cannot happen together. So those two events are called as mutually exclusive event. Fine. Next one is very important concept. It is complementary event. Complementary event. So any event is said to be complementary event. Generally, if A is event, its complement is denoted by A bar. So any event is said to be complementary event if it is non-occurred. For example, let me take A as an event of getting head. Fine. If you toss a coin, let me take an event as getting a head. Why? Because it is an event. Each and every possible outcome is none other than event. So getting head is one of the event for this random experiment. Fine. So if A is a event of getting head, then its complement is represented by A bar. A bar is none other than not getting a head, right? Not getting a head in the sense, what is the meaning? When you toss a coin, when you're not getting the head, meaning is you're getting a tail, right? Getting a tail. So they are complementary event. So complement of not getting a head is getting a tail. Similarly, complement of getting a head is not getting a tail. That is getting head. Both are same. I'll just repeat once again. Suppose if I have an event as getting a head, complementary is not getting head. So not getting head is same as getting a tail, right? Not getting head in the sense only possibility is getting tail. Similarly, not getting tail is only possibility is getting a head. So they are complementary to each other. So we say those two events are complementary event. Clear? Next concept is independent event. Independent events. As the name itself suggests that they are independent. So two events are said to be independent if one output does not depend on other output. Suppose if you toss a coin, getting a head is one event and getting a tail is another event. So one is clearly not depending on other. So they are said to be independent event. And the next is equally likely event. Ninth one, equally likely event. So two events are said to be equally likely event when one does not occur more than often. In the sense, I'll give you simple example. If you're going to throw a die, getting 3 on one toss on die. I'll give you example. I'll just repeat once again. In the sense, if you're going to throw a die, suppose if you're going to get 3 one time. So total number of possibilities is 6, right? So either you will get 1 or 2 or 3 or 4 or 5 or 6. Total number is 6. How many times you have obtained 3? It is 1. So 1 by 6 is its probability. Anyhow, I will tell you later. Suppose if you are going to get a number 5 and throwing a die, how many times you are going to get 5? It is 1. So totally 6. Total possibility is 1 by 6. So they are having both same probabilities. Chances of occurrence of these two numbers are same. That is, probability of these two occurrence of a numbers is same. So that kind of event is called as equally likely event. Fine. Next one is exhaustive event. Exhaustive event. A set of events is said to be exhaustive if the set includes all the possible events. Fine. I'll give you an example. Suppose if you are going to flip a coin, toss a coin, we obtain head or tail. Right? This includes all the possible event. When a coin is tossed, it should be there is a possibility to get head or there is a possibility to get tail. So if it includes all the possible events of all the probabilities of all the possible events of occurrence, then we can say that is an example for exhaustive event. Fine. And coming to the concept of probability, as I already told you, it is a chance of occurrence of event. That's all. And always remember, probability of any event lies between 0 and 1, and you should not express it in terms of decimal. It is better to express it in the form of fraction, A by B form. You should not simplify it further. Fine. So probability is another than it is a chance of occurrence. Further, formula to calculate the probability, whatever I have explained, I will give you the same definition in notes. So formula is given by number of favorable cases divided by number of equally likely outcomes. For example, if you are going to toss a coin, so total number of possibilities is 2. Either you should get head or you should get tail. So total number of possibilities is 2. So probability of getting head is only 1, right? So 1 divided by 2. Probability of getting tail is 1 time. So 1 divided by 2. When you toss a coin, 1 time. So this is the probability. Since they are equal, we can say it is exhaustive event. Fine, or equally likely event. So that is the concept of probability. Now let me discuss some laws of probability. So here you have a laws of probability. So you have to memorize this. So as I already done this concept in your first sem. So whenever you have a term union, you have to consider it as R. So intersection stands for AND. Fine. Now first property of probability, that whenever you have probability of difference of two events, that is A2 minus A1, we can write that as probability of A2 minus probability of A1. Similarly, probability of sample space is equal to 1. S is none other than sample space. So whenever you are going to get all the sum of probability, sum of the probabilities of sample space, you will get the value as 1. You just remember this property. Anyhow, I'll let you know this later while solving the problems. So probability of null set is always equal to 0, and the relation between probability of any event and its complement is given by this relation, as you already familiar. That is probability of an event A plus probability of its complement is equal to 1. Thereby I can manipulate like this. So this is one of the important concept as we are using this property in solving the problems. You just memorize this. Next one, if we have any mutually exclusive events, n number of events, if you are going to apply probability for that, union will become plus. So probability of A1 plus probability of A2 plus probability of A3. Fine. Fifth property, it is very important property as we are using this, and the third property in solving the problems. So whenever you have probability of AR, as I said, union is none other than R. AR B, if they ask you to find A and B, you have to use this formula. So remember this formula, and further A intersection B is given by this formula, and again A intersection B is given by this relation. So where B divided by A is none other than a conditional probability. Anyhow, I'll let you explain this concept in the next session as you have in depth of that concept. So I'll explain in the next session. So this is called as conditional probability of B with respect to A with respect to B. So from these two expression, I can write probability of A intersection B as probability of A into probability of B, where A and B are two independent events. So these are the properties of probability, laws of probability. You have to remember. Anyhow, I'll just solve 2 more questions in this session. So I'll next start with the concept in depth, conditional probability. I'll do it in a later session. So here is a note. I have already given this note in first sem also. So whenever you have problems related to cards, you have to memorize this. So totally you have 52 cards, among which 26 are red color and 26 are black color. Again, in 26 cards, you have 13. One is hearts, diamonds, they are of red color. Spades and clubs are of black color. Again, face cards will be 4, that is Jack, Queen and King. And one more card is Ace card. Number 1 is card is Ace card. Anyhow, we are going to consider that as a face card as well. So totally we have 12 number of face cards. Fine. Now let me solve problems, 2 mark questions based on the concept. So here is the problem. They are important for 2 mark. So after writing the concept, you just put a heading problem and please take the running notes. From a bag containing 10 red balls and 20 black balls is drawn at random, what is the probability that is red ball? So bag contains 10 red balls and 20 black balls. So we have to find the probability of getting a red ball. First write down the formula. That probability of getting red ball is probability of red ball is equal to number of, you have to write the formula for 2 mark question, you should not skip it. Number of favorable cases or number of favorable outcomes divided by total number of outcomes. You just write enough. Fine. Now number of favorable cases divided by total number of outcomes we have. We have to find the probability of getting red ball. First you have to find total number of outcomes, in the sense how many how many balls are there. So red color balls are 10 and black color balls are 20. So total balls are 30. Right. So number of favorable, in the sense favorable event here is probability of getting red ball. How many red balls are there? 10. So that will be the favorable cases. So probability of getting red ball is 1 divided by 3. You should not keep it in decimal. You just stop here itself. Fine. Now look at the second question. Find the probability of getting a head in tossing a coin. So similarly you have to write the formula here. Tossing a coin. Probability of getting head, right? So probability of head is equal to, you just write down the formula, whatever I have written, you just copy down the formula. I'll just write the steps. So probability of getting a head, you have to write the formula, don't skip it. So probability of getting head is none other than, when you're going to toss a coin, what is the probability of getting total outcomes? Either you should get head or you should get tail. So total is 2 outcomes. Favorable outcome, in the sense how many times you are going to get head when you are going to toss a coin. Single time, that is 1, right? Only one time you can get head. Total number is 2. So 1 by 2 is the probability of getting head. So here is the third question. Find the probability of getting a king card in the pack of 52 cards. So as I already given a list of cards, totally we have 52 cards, among which we have total 4 king cards, 4 queen cards and 4 jack cards. So total we have 4 number of king cards. So find the probability of getting a king card in a pack of 52 cards. So total cards is 52. So first write down the formula. Probability of event is equal to, what it is, the number of, you have to write the formula for each and every problem. I'm not going to write it for all the problems. Number of favorable cases divided by total number of equally likely event. Equally likely cases. Fine. So it is given by probability of event is, number of favorable cases is, number of king cards is 4. Total number of equally cards is 52. So 4 by 52 is the required probability. Clear? So here is the next problem. We have to find the probability of getting a king or queen. So the word or is given, as I already told you, whenever you have or, you have to use union. Whenever you have and, you have to use intersection. So remember, whenever you have or, you have to use union, and in the sense you have to use intersection. So we have to find the probability of getting a king or queen. Fine. So here we have 2 events. Let us take A as king cards. Fine. So B as queen cards. We need to find probability of king or queen, in the sense we have to find probability of A, or in the sense we have to use union B. So A union B we have to find out. As I already given the properties of probability list, R in the sense union. So you have to use this formula. Fine. So probability of A union B, we know that it is a property. Is A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now let us find probability of A, probability of B and probability of A intersection B. So probability of A, in the sense A is an event of getting king card. Getting a card which is king, or getting a card which is queen. So probability of A is getting a card which is king. So total number of cards is 52. First you have to write the formula for probability of an event here. Fine. So probability of total card is 52. Probability of getting a event A is, that is getting king card is, how many king cards are there? 4. So it is 4. Similarly, probability of getting a card which is queen, B is queen. So it is total number of cards is 52, among which 4 cards are queen. Fine. Now we have to find A intersection B. A intersection, in the sense, as you already familiar in the sets, that intersection in the sense it represents the common element, right? So A is a king, B is a queen. Do we have any common nature between those? We don't have. So it is null set. If A intersection B is null set, as I already given in the property, that probability of A intersection B is none other than a probability of null set, right? So probability of null set is 0. Therefore, we can write probability of A intersection B as 0. Now let me substitute all these values. You will get probability of A union B is equal to, probability of A is 4 by 52 plus probability of B is 4 by 52 minus probability of A intersection B is 0. So let me take LCM 52. So 4 plus 4. You will get 8 divided by 52. This is probability of A is none other than getting king or queen. Right? Getting king or getting queen. Therefore, the required probability of getting king or queen is 8 by 52. So I have considered getting king cards as a event A and getting queen cards as an event B, and I have used the properties of probability. Hope so it is clear, right? So here is the next problem. We have to find the probability of occurrence of exactly 2 heads in 3 tosses of a coin. Here we are going to toss three tosses. I mean, one coin is tossed 3 times. Fine. So head in 3 tosses of a coin. So we are tossing a coin 3 times. So we should find the probability of occurrence of exactly 2 heads. In the sense, we should estimate the number of possibilities where we have exactly 2 heads. Right. First, let me write down the sample space. In the sense, let me write all possible outputs. Since we are tossing it in 3 times, right? I'll give you a short hint to remember it. First, you whenever a coin is tossed 3 times, you will get 8 chances. I mean 8 possibilities. So for that, you just write down head 4 times and tail 4 times. Then head 2 times, tail 2 times, and then head, tail, head, tail, head, tail, like this. So these will be the sample spaces. You just list all these possibilities in a sample space. Head, tail, 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 head, head. I just written this in order to memorize, that's all, nothing. So these are the possibilities when it is tossed 3 times, that is 3 tosses of a coin. So these are the possibilities. Now we have to find how many times we have head exactly 2 times, that is exactly 2 heads we should need. Now let me write down the total number of cases. So total number of possibilities is, total number of possible cases is how many times? 1, 2, 3, 4, 5, 6, 7, 8. If you want, you can check. Other than these possibilities, you don't have any other choices. So only choices is these 8. Fine. Now favorable cases. Favorable in the sense what we need? Favorable cases, exactly occurrence of exactly 2 heads. So let me list it. Exactly 2 heads in what are the cases that we have exactly 2 heads for? So let me write down those. So first one is exactly in the sense you should have only 2 times head. Here we have 3 times head, so we cannot write this. Next, exactly 2 heads. So HHT, exactly 2 times we have. Again HTH. Again exactly 2 times I have. Here we don't have 2 times, we have only 1 time. So here again you have THH. So in none of the cases we have 2 times. So favorable outcomes is 3. Therefore, probability of what it is? Probability of I'll just write statement. Probability of getting exactly 2 heads is equal to what it is formula? Favorable number of favor. You just write down the formula. Number of favorable cases divided by total number of likely cases. You have to write the formula clearly. I'm sorry, I cannot write all the formulas again. You just write it down. So total number is 8. Favorable is 3. So the required probability of getting exactly 2 heads is 3 by 8. So all these problems are simple. You have to understand the logic. Anyhow, you are familiar with this. So you write down the formula clearly. I'm sorry, I cannot write all the statements here. You just copy down the formula as I given in the definition. Hope so it is clear for you. So here is the next problem. Anyhow, you have already solved such kind of problem. A bag contains 3 white balls, 5 black balls and 6 red balls. If a ball is drawn at random, what is the probability that is either red or white? The minute R and R and the term and comes, you have to remember whenever you have R, it is meaning that union. So you have to use the property of probability, that is probability of red ball or white ball. So I will write it as R union white ball is equal to probability of R plus probability of W minus probability of R intersection W. This is from the property probability of union. It is A union B is equal to probability of A plus probability of B minus probability of A intersection B. I have given this property in a property list. You should go through that. So A is an event of red ball, B is an event of white ball. So I have replaced there. Now let me find the terms probability of getting red ball. Right? Before that, first let me write the number of balls given. Total number of balls. How many balls is there? 5 plus 3 plus 6. So total number of balls is 14 balls. Number of white balls, whatever the given data, I am just writing it. Number of white balls is 3. Number of black balls. How many number of black balls is given? It is 5. Number of red balls. How many number of red balls is there? 6. Fine. Now let me write probability of getting a red ball. That is what the probability of R is. Probability of R is probability of getting a red ball. So how many total number of you just write down the formula here again. Formula, what is the formula? I have already given in a list. So you have to write down the formula. I'll just write here number of favorable cases divided by total number of likely outcomes. So what is the total number of favorable outcomes? What is the total number of red balls? You have 6. Total number of likely outcomes in the sense how many total number of balls is there? 14. So probability of R is 6 by 14. Similarly, probability of W is none other than probability of getting white ball. So how many white balls are there? 3. Total number of balls is 14. So it is 3 by 14. Now we need to find R intersection W. R intersection W is none other than, do we have any common property between red and white balls? We don't have. Fine. So similar to the previous case, it is also null set. So when you are going to take probability over a null set, the value will be 0. So substitute all this in a formula. So I can write probability of red or white ball is equal to probability of R is 6 by 14 plus probability of white is 3 by 14 minus probability of red intersection Y is 0. Now you take the LCM 14, 6 plus 3. So you will get 9 divided by 14. You have to write the conclusion. Therefore, the probability of getting either, you have to write the conclusion for each and every problem. Red or white ball is equal to 9 divided by 14. Fine. So you have to write the formula. Formula is mandatory in all the problems. Try to write the formulas, the properties clearly. So hope so this concept is clear. And few more problems I'll continue in the next session. Hope so whatever I have done in this session clear for you. Further, if you have any queries, you are free to ask me. Thank you. Continue in the next session.